In this second part of 6.4, we're going to talk about how you can rationalize a denominator, because in fractions or in any of these problems that you're going to start seeing from now on, you cannot leave a radical inside of a denominator. If it is, it's not simplified as much as possible. So we're going to talk about how to do that and then how we can solve quadratics using square roots, basically. So we're first going to start with rationalizing a denominator. The easiest way to explain rationalizing a denominator is basically using the opposite. So I've got example 1 here, and this is really the most complicated version. We're going to get it out of the way, and I'll show you another very easy version of it. If we have, obviously you can see we have 1 over 5 plus the square root of 6, but we can't leave it as is because there's a square root of 6 in the denominator. So what we're going to use is what's called the conjugate, and the conjugate is basically like the opposite. So I'm going to multiply by the opposite of the denominator. Well, what is the opposite of this? It would be 5 minus the square root of 6. And whatever you do on the bottom, you're going to do as well on the top. And then basically it's going to be some foiling. So on the top we have 1 times this whole thing, so that's going to stay the same, 5 minus the square root of 6. And then on the bottom we're going to do FOIL. Now I'm going to kind of do this off to the side so you can see what it would look like. We have 5 plus the square root of 6, and then times 5 minus the square root of 6. We do first outside, inside last, so first is going to get us 25. I'll write this down here. Then the next one, 5 times negative square root of 6 is going to get us negative 5 root 6, and then do the inside, that's going to be positive 5 root 6, and then when we do the last, remember square root of 6 times the square root of 6, that's the same as the square root of 36, which is just 6, so that's going to get us a negative 6 because there's a negative sign here. Alright, so now we can go ahead and simplify. What you should notice is that those middle terms with the radicals should cancel out. That's kind of the whole point of multiplying it by the opposite, by the conjugate, because those are going to cancel and we're going to just be left with a number on the bottom. And then the last step is just to combine like terms. So on the top we still have 5 minus the square root of 6, and then on the bottom we have 25 minus 6, which is going to get us 19. So that right there is going to be your final answer. 5 minus the square root of 6 over 19. Now it may not look simplified, okay, but you never want to have that radical in the denominator. Now, a simpler example to this would be something where you just have 1 radical on the bottom, so maybe the square root of 3. So I have 2 over the square root of 3. In this case, you don't have to multiply by the opposite, it's just by whatever the bottom is. So the only time you're going to use the conjugate is when you've got a plus or minus there. Alright, if it's got no plus or minus, then you're just going to multiply by whatever the bottom is. So here would be the square root of 3 on the top and bottom. Okay, and so on the top we would just get 2 square root of 3, and then on the bottom square root of 3 times square root of 3 is the square root of 9, and obviously that simplifies to 2 root 3 over 3. Alright, so there's your answer. Okay, so if it's just 1 radical, no other numbers, then you're just going to multiply by the denominator, whatever it is on the top and bottom. If you've got plus or minus anything, then you're going to have to use the conjugate, and you want to make sure you write down what a conjugate is. That's a very important word to remember, that it's going to be the opposite of whatever the denominator is. Okay. The next part is just if we're solving quadratics with square roots. The beginning problem, example 2 here, should be super easy and quick. Number 3, you're going to have to just make sure you're paying attention to your steps. But the key, and I put this down at the bottom here, is to always make sure that the squared part, so your radical or whatever, is going to be on its own before you take the square root of both sides. It's extremely important that you move everything else to the other side so that the square root is on its own. So let's look at example 2. It says s squared equals 169. Well, the easiest way to solve for s is to just take the square root of both sides because s squared is by itself. And when we do that, remember a square root and a square cancel each other out. So we're left with s equals, well, what's the square root of 169? There's 2 answers to this. All right, so it's going to be positive 13 and negative 13. And that's also important that you remember in this whole section from now on, that you're going to have 2 answers for a square root. I know before we've kind of typically just gone with the positive answer, but now I want you to make sure you're writing plus or minus because that will be important later when we get into quadratic formula and imaginary answers and so forth. Alright, so s is going to be plus or minus 13. Now number 3, this example, this one's a little bit more complicated. Notice that this right here is our squared part, okay, but is it by itself? No, because we have this negative 18 here and we have the 7 out in front that we don't want. So we need to move everything that we can over to the other side first. Think of reverse PEMDAS. I know that's how they told you when you were in algebra maybe, or even in 8th grade to solve. So what we're going to do first is add 18 to both sides. And we get 7 times x minus 4 squared equals 28. And then we want to get rid of that 7, so we divide everything by 7. And what we're left with is x minus 4 squared equals 4. And now the square is by itself, so we can take the square root of both sides. So I square root both sides. Remember, my square and my square root cancel, and I'm left with what's underneath, which is just x minus 4. Well, what is the square root of 4? Remember, there's a positive and a negative answer, so it's going to be plus or minus 2. Okay, and then we want x to be by itself, so the last step is just to add the 4 over. So we're going to add 4. Okay. So in this type of problem, unlike the last one where it's just simple square root, you're going to have to do a little bit of extra work because you're going to have 2 answers here you have to solve for. So we get x is equal to plus or minus 2 plus 4. So you're just going to go ahead and figure out what those two numbers are. So the first one is when x is equal to positive 2 plus 4, which gets us 6, so there's one answer. The other one is when x is equal to negative 2 plus 4, which is going to get us positive 2. So there's our 2 potential answers for x. X could equal 6 and x could equal 2. Now, one thing you do want to make sure that you check, and it will definitely say this in the directions in your book if you have to double check for sure, is if there's any extraneous solutions. Remember, extraneous means it's an extra solution that you get, but when you plug it back in, it's not actually going to work. So what you would do is plug in x equals 6 into your equation and make sure that you get 10, and then plug in x equals 2 into the equation and make sure you also get 10. And if one of those doesn't work, then it's not an actual answer, so you would just cross it out. All right? So just make sure you double check your answers every time. It doesn't take long, just a quick mental math or calculator work, and make sure you're getting the correct answers there, because that's something on a test or a quiz I'll definitely be looking for, because there is a chance you could have extraneous solutions. And just a quick side note, and this will be the last thing for these notes, for number 38 in your application problems, if you have a question on where to start, please make sure that you look at example 5 on page 269, because the formula that you want to use is actually in that example. And then once you get that formula, the rest of the problem should be relatively easy. So look at that example first, get the formula from there, and then you should be good to go. And if you still have questions, please make sure you ask. Thanks for listening.